This instructional video is designed to demonstrate how to quickly and efficiently determine the pH of a strong acid or a strong base. And I have 3 examples written here. The main thing to remember is that when you have something that is identified or known to be a strong acid or a strong base, it will dissociate completely. And so your sodium hydroxide will become sodium ions and hydroxide ions, which makes this a base. And the entire concentration here will contribute to these ions. So we will be 0.05 molar in sodium ions and 0.05 molar in hydroxide ions. And this is the important part, because taking the negative log of hydroxide concentration will allow us to find a POH. So this POH is the negative log of 0.05. The POH is 1.3, and because pH plus POH gives us 14, if we subtract this value from 14, this will give us the pH. And so our pH value in this case is 12.7. We do the same thing for hydrochloric acid. That will dissociate into hydrogen ions and the chloride ion. The entire concentration will convert over, so we will have 0.1 molar in the hydrogen ion and 0.1 molar in chloride ion. In this case, we can take pH directly. So we have the negative log. 0.1 is 10 to the negative 1. So this one becomes very easy to determine. We will have a pH of 1. So our final example, lithium hydroxide, also known to be a strong base. This will dissociate completely into lithium ions and the hydroxide ion. We will have 0.025 molar lithium and 0.025 molar hydroxide. We can determine the pOH as we did in our first example, taking the negative log of 2.5 times 10 to the negative 2. And when we take this value, we get 1.6. So if the pH is equal to 1.6, if the pOH is equal to 1.6, then to find pH, we subtract that from 14, leaving us with a pH value of 12.4. So this demonstrates how we use the fact that strong acids and strong bases will dissociate completely to give us concentrations of either the hydroxide ion or the hydrogen ion. And once we achieve that result, we simply plug it into the pH or pOH formula to get the value for the acidity or basicity.